everyone.
All right. Let me just move my screen out of the way and we'll get started. Welcome everyone, and thank you so much for showing up today. As we're all aware, spring at least in the northern middle of the United States, upper Midwest, is coming up soon. That's definitely going to be different where you guys are at, but very exciting times. Just to get us started here, Rainbow Ecoscience went through a name change as of November 1st, 2021. What our new name change now is encompassing the entire green industry, including the landscape market. We find that taking the tree care out of that name really encompasses that future and what we're looking at. I also want to mention that we became employee owned. So we weren't bought out by a bigger conglomerate, but we were now self-owned and with the same great folks and the people to bring you the best predictable and practical results in the industry to provide the most secure and best plant health care for your clients. A quick safety brief, because as many of you know, safety is very important to the folks here at Rainbow Ecoscience. So as everyone is going throughout their day, if you wouldn't mind just please making sure you're checking your surroundings. If you're sitting in an office space, make sure there's no trip hazards nearby. If there's any inclement weather that's in the forecast, just be aware of that. Depending on where you're at in the world, you're definitely going to have different stressors and abiotic things happening, right? So be aware of all those. And then also, if you're driving, just make sure that you're parked in a safe location or that you have the phone just away from you and maybe on speaker so it's not taking away from active driving if you are on the road. A little bit about myself. My name is Cory McCurry. I am the arborologist for the Midwestern part of the United States. I have my background is my background is in biology. I graduated from a university in Kansas called Fort Hays State University with a minor in biology and chemistry. I'm an ISA certified arborist, and I've been in the industry for about 8 or 9 years now. I currently reside in Chicago, and in my past experience, I was a plant health care coordinator, a technician, and I was a consulting arborist for North Chicago for about 3 years. So I have a lot of practicality background. If any of you are coming from the plant healthcare side of things and you were a technician or an operator or manager, I can definitely relate to you, not only in the role that I am now, but the role that I had previously. How I serve you through Rainbow Ecoscience is I provide a lot of training and education on plant healthcare protocols, technical support, field support, and product and equipment support, including plant healthcare education. So if you guys have any questions that come up in your daily routine of plant healthcare, please don't hesitate to reach out to myself, where my number and my email are listed just there underneath the name. And if I don't answer, please reach out to someone at Rainbow Ecoscience. For this webinar, we ask that you save your questions for the end of the panel. If you have questions, please type them into the Q&A box and we'll answer them at the end of this presentation. This webinar is being recorded and a link will be sent out after the webinar if you'd like to share that or rewatch at another date. This webinar is worth 1 ISA CEU, and if you did not enter your ISA certification number during the registration, please type that into the Q&A at this time. All right, so that gets the particulars out of the way right now, guys. So let's go ahead and just get started. Today, we're going to be talking about abiotic stressors, how to manage and identify in our urban environments. This topic is a very fun topic, but one that's really confusing because there's a lot of subjectivity and metrics that go into it. And today I'm going to kind of paint a roadmap for us on how we should anticipate learning about abiotics and or biotics and abiotics. And so we'll kind of differentiate the differences. We'll go into differentiate them, and then we'll go to define what some of those are in our urban environments. Keeping in mind, I am really a urban arborist. I don't really have much practical experience in forest settings, though I do believe trees are going to be reactive to certain stressors that have some similarities there. So for today's agenda, our outcomes are going to be going over abiotic disorders. We're going to be talking about chlorosis, symptoms, and diagnostics. We'll then jump into a brief soil overview. I say very brief because, as many of you know, soils are very important for the health of trees and the microorganisms of the biome. And so generally soils can take anywhere from hours to days to years to learn about. So we'll go a very brief overview over that. Then we'll get into some cultural management strategies that we can help reduce some of these abiotic stressors and disorders. Finally, we'll follow up with some other management options that would help mitigate some of these issues that we're seeing in maybe urban or forest settings. So first of all, let's define what abiotic disorders are. Well, an abiotic disorder is caused by non-living factors such as drought, stress, sun scald, freeze, injury, wind, injury, chemical injury, nutrient deficiency, or improper culture practice such as overwatering or poor planting. A very important note here, I will say it is caused by non-living factors. Something that many of you may not know is deer grazing are actually considered non-living factors. This is really important because most of the time, deer are not going to cause symptoms that are going to be reoccurring, and they're not going to cause disease to be spread, which is kind of counterintuitive to when you start to read into what is a biotic disorder. A biotic disorder can be defined as a living pathogen, such as a bacteria, fungus, nematode, mite, or insect that causes tree or shrub damage. Before we get started here on the kind of diagnostic process to try to develop what it is that we're looking at when we're going to identify what's causing stresses to our trees or shrubs, I just wanted to mention too, and this is kind of nonchalant, I forgot to do it in the intro, happy St. Patrick's Day, everyone. I did forget to mention that I am Irish background. This holiday does mean something to myself and my family. So I just wanted to throw that out there and thank you guys for being a part of this on a holiday. So let's just jump back in here, diagnostic approach. What this means is this is kind of that discovery phase that we all need to go through to figure out what it is that we're looking at in our settings or our clients' property settings to establish what it is that they're dealing with. We need to do a lot of information gathering at during this diagnostic approach. That could include site information, such as when the landscape was established. What is the irrigation schedule? What products have been applied to the plants? So that's site information that we should probably collect. And that's just a few questions we should ask ourselves. These are not, this is not an exhaustive list. There are many, many others, as you guys will tell as we continue to go down this path. We also need to know what hosts are on the property. If we don't know the host, we don't know what diseases those hosts are susceptible to. As many of you know, many diseases and pests are dependent on certain host species. So what are those common pest problems and what are the common cultural problems that we should be expecting? And that's going to help us to better identify if this is an abiotic or biotic issue. We also need to do recorded observations. We need to have a certain visit interval and treatment interval planned out to collect this data to make sure that we're staying appropriate on what it is that we're trying to find. In the picture here, I just wanted to illustrate that this would be a abiotic issue because it is probably anthropogenic, meaning human caused due to planting. This is a poorly planted site. We can see the left tree there is a correctly planted. We have a nice root zone. It's not planted too deep or too high. The other two are planted too high, and the one on the far right is planted too low. It looks like the reason they did this is to achieve the same aesthetic equilibrium on the top. However, they're doing this at the compromise at the bottom, and so you're really setting these trees up for failure from the start. An abiotic issue that arises a lot of times in the city with folks who are either doing planting themselves and don't know, or maybe practitioners that are new to the industry and are still not aware of how to appropriately plant trees or shrubs. Finally, let's go ahead and define abiotic issues here. Abiotic is going to be non-host specific. It often affects several species or plants of various ages. This is really important because it's counter to what is normally caused for biotic. So it's generally non-host specific, and it's going to affect several species of plants at various ages. So as you're going out and you're doing this discovery to try to figure out what it is you're looking at, just keep this in mind. If you're seeing it on multiple hosts in a certain area and a certain time, it could be an abiotic causer or stress. Now, there's going to be patterns of symptoms relative to environmental or physical or cultural practices may be regular or uniform. So the key here is the symptom, does it show a pattern? And if it does have a pattern, is it going to be related to the environment, physical or cultural practices that may be occurring on the area? Are we having frost damage? Has the technician changed the watering cycle on the site? Those are kind of things that kind of go into that pattern of a symptom. The symptom rate, the extent at which the damage is seen, is usually uniform. And so that damage appears similar among plants. And so if you're looking at an abiotic issue, you're generally going to see a symptom rate that's uniform across all stages. You're going to see it over several species of plants at various ages. And it's just going to have a very sort of similar appearance going throughout, relatively uniform. A sign, there is no sign or evidence of kinds of pests or pathogens known to cause the current symptoms. So if you're looking at a plant and you know the host and you know what that host is maybe subjective to, or can be prone to have certain diseases, you may understand that abiotic, you may not see let's say fungal mats or frass or eggs. So those are going to be things where you don't see signs of evidence. That may indicate this you're looking at a abiotic stressor or non-living cause of damage. Finally, it is not infectious. So if it's abiotic, you shouldn't see it shouldn't be non-infectious. The spread is not progressive. Commonly caused by one incident and does not spread. So if it should be a localized necrotic symptom. A lot of times here in the city of Chicago, I see a cultivar arborvitae. Most of the time they are very prone to winter desiccation, salt, and underwatering, or overwatering. And so I often see abiotic stressors related to that tree species here, but you can definitely tell that it's not a clear spread. You'll have a row of 20 that are maybe planted too close in some instances, and you'll have 5 at one end die and maybe 3 at the other end, and then maybe a certain amount in the middle that are still looking very healthy. So with abiotic, just something to keep in mind, it is not going to be progressive. Something I wanted to highlight here, because they're in red, is there needs to be a clear, I think, difference on what a sign and a symptom is. So a sign is objective, it's observable, it's a phenomenon that can be identified by another person. Examples of this would be fungal fruiting bodies that I had mentioned earlier. A symptom of a plant disease is a visible effect of a disease. Its symptoms may include a detectable change in color, shape, or function of the plant as it responds to either an abiotic or a biotic stressor. So those are the symptoms. That's the difference between a symptom and a sign. You often have folks ask you, hey, what's the symptom? Hey, what's the sign? And just understanding what the difference is there will help you kind of develop what whether it's abiotic or biotic. Moving along here, we'll just go ahead and get this last one. And reoccurrence. How often are we seeing this reoccurrence? Is it possibly previously associated with current or prior environmental conditions or cultural practices? Are you seeing a lot of volcano mulch out there? Over mulching? Has it been a frost? Has there been construction nearby? Is there compacted soils? Those are questions that we need to ask ourselves, is what's the reoccurrence rate that we're seeing this at? Understanding this will give us a very clear idea if we're dealing with an abiotic or a biotic. With biotic, we're going to go through these really quickly, but it's important to see that it's really almost counterintuitive to everything we just went over on abiotic. With biotic, it's going to be host specific, often affect one species or cultivar at the same age. So, this is general, guys. This is not always the case, but in general, this is how we should look at abiotic versus biotic. Host specific could mean that, example, we deal with a pathogen some of you may not know, but it's oak wilt, a fungal pathogen that really attacks oaks, specifically red, white, and live oak. Knowing that little bit of background indicates to me that that could be a biotic symptom for some of those host trees. So understanding the host, understanding the different factors of stressors that are biologically related out there are very important. I think that most of the time, this conversation between abiotic and biotic is very difficult for people to understand because it takes, in my opinion, years of training and practical knowledge associated with lab technologies to really kind of figure out what it is we're dealing with. It's really easy to stand here and say, oh, these are the general things you should see. But once we get out in the environment, we all know it's a lot different when we're on that site. Some patterns and symptoms are initially observed at random or irregular locations. So those symptoms will be kind of irregular location. They'll be a little bit more sporadic, not as uniform like we saw in abiotic. And then we understand that the rate will be relatively uneven. The time of appearance of damage severity varies among affected plants. It may be uneven, and it may just take a little bit more time to progress. Sometimes, going back to the oak wilt example, red oaks generally will decline in 4 months if they get oak wilt and die. There's really nothing you can do to save them. White oak, on the other hand, will take maybe years to decline, and it may even overcome that disease if given a little bit of help from plant health care or practitioners in the industry. Sign for this one are going to be kind of inherent. We're going to see insects, for example. We may see mites on the plant, the underside of leaves. We may see fungal mycelium, kind of that white mat that's associated with fungals, especially on root flares. If that root flare is compromised by like maybe an open wound, we may see spore clusters, bacterial ooze, and products produced by pests like secondary metabolites, thinking honeydew or sooty mold if we're looking at scale, specifically like soft shell scale. An example that I would use up north would be like magnolia soft shell scale, where it's actually taking the phloem of that tree and then using it to create this honeydew and precipitating it, causing all this black mold underneath. Those are signs. I think it's pretty inherent that that's the difference here, but it's always important to just bring that up just so we're all aware of what the difference is there between sign and symptoms. Infection spreads over host over time if environmental conditions are suitable. I like this one because most foliar fungal diseases are definitely going to be dependent on environmental conditions. Fungal pathogens need water. They require it to complete their life cycle. And if we're overwatering or inappropriately watering, especially some of our more coniferous trees, we could see things like Dothostroma, Rhizosphaera, needle cast sort of occurring because we're creating a suitable environment for that infection to spread. So the sign there is that fungal spore and the infection spreads over time if environmental conditions are suitable. Reoccurrence is usually associated from pest and pathogen known to commonly affect species. So if you know those stressors are in your particular area, whatever it may be, disease or pest, it's always important to keep that in the back of your mind as you're going through this observation process. A little long-winded here, guys, and I'll keep going kind of quickly. I know we need to speed up just knowing how many slides I have, but I just wanted to get that clearly stated so that we kind of know what we're looking for in the differences between abiotic and biotic. Something really useful in the industry that I often rely upon is this really nice fact sheet from the Ohio State University. This is Joe Boggs et al., Eric Draper. They've came up with this really nice 20-question plant diagnostic package that you can get online and print out. It's a really great and comprehensive kind of diagnostic fact sheet to help figure out what's going on in the environment. And these are often questions that we should ask ourselves as professionals in the industry to kind of identify what it is we're looking at. Some of those questions include, what is the plant? Going back to biotic versus abiotic, we know that the host is definitely going to be specific. Most hosts are going to be prone to certain diseases and pests and pathogens. What is normal for the plant? Normal meaning, what should it look like in its natural environment? If it were in a forest setting, what should that plant be in appearance or growing under to be normal? So I won't go over all these, but you can see here that lots of great questions that could help us kind of identify the differences between abiotics and biotics in general. Where do trees grow? Well, we all know they generally don't grow in the urban setting. We kind of encroached on them many years ago, maybe around 7,000 years ago or so, when first modern cities were born, but are kind of developed. We know they grow in forest settings where there's a nice organic layer. There's constant decomposition on that forest floor of the nutrients via fungal or bacteria that are decomposing those nutrients and recycling them for the roots of the trees to reuse. There's a lot of woody stems that are being dropped throughout this time. There's a lot of healthy competition that dictate what is a nice healthy forest, and this naturally occurs. But this is where trees should grow, right? Where do we try to put trees? Well, one example here, we put them in restricted root spaces, poor soils, inadequate soils, inadequate soil moisture, and then we have reflected heat islands like in our urban settings where we know that this is probably not the best place to put trees. So a lot of abiotic stressors will be noticed in urban environments. I would probably say more so than forest, just because of the anthropogenic or the human causation of certain demises, like we'll see here later. Before we get into that, I want to bring up this really cool token. This is something I use all the time in the field and practice. This is kind of the spiral of doom. Just above that predisposing factors there, we could imagine a healthy tree starting out there. We have a healthy tree and all of a sudden we put that healthy tree in an urban environment. Well, that's a predisposition factor for kind of this spiraling down of decline. As we spiral down, that kind of gets tighter and tighter. And so that tree is continuously being stressed out. So let's say we have a tree that's healthy, it's in an urban environment. So it's already kind of at risk to kind of go down this spiral of doom. Let's say we have an inciting factor. So we have a tree in an urban environment, all of a sudden we have a defoliating insect. Now that tree is even more stressed and it starts to kind of go down this spiral of doom. If we don't intervene as practitioners at any stage in this development, this tree may be continual decline, maybe a continuation of decline. Finally, we have a contributing factor here in the center. That could be the canker fungi or the wood and bark boring insects. And finally, if none of those things are mitigated or helped at a certain life stage in the tree's life cycle, it could lead to ultimately death. And so that's kind of the spiral of decline there. A really good example that I wanted to bring up here is this is a forest setting versus an urban setting structure. This is not my slide. There on the bottom, we can see the reference adapted from Franklin et al. In 1987, and then we see Hilbert there et al. In 2019. But I think it's a really nice diagram because it's a hypothetical solution. Here on the left, we have a hypothetical Douglas fir in a healthy forest setting. It is already in a crowded stand. We can see here that we start out as a healthy tree on the top. It's in a crowded stand, and so naturally in a forest, there's going to be competition. When we look just to the left of competition, we notice this little checkered line. Well, that means it got out of the spiral of doom because it outcompeted its neighboring trees. So therefore, it'll be the dominant tree, and it'll kind of continue to live a healthy lifestyle unless there's another factor that puts it back in this kind of spiral of doom. We can see that in a forest setting, it may be suppressed by, if it doesn't become the dominant tree, it'll be suppressed by other trees. Perhaps there's a storm event or maybe human event that removes a tree, and we release that tree to be the dominant tree, and it gets out of the spiral of doom. However, if release doesn't occur, we can see that it may keep going down the spiral, and a defoliation event may occur. The defoliation event may not be the last straw for that tree, and it could recover and get out of the spiral. We can see that if it doesn't get out of the spiral, it will ultimately lead death. And that's just a few that we see in a healthy forest setting. Now, when we look at a tree and we put it into an urban setting, we have a lot more dynamics that are involved, such as, are we putting in commercial planting sites? Are we adding nutrients back to that soil to help those trees that are lacking that because they're not in a nice forest setting, where oftentimes there's grass in everyone's yard, and so they're always competing for those nutrients, and everyone's mowing their lawn and removing their leaves, and so there is no kind of cycle. So Are we implementing a nutrient management plan? We could, and we could get out of this cycle. If we don't, we may continue, and we may plant that tree in limited root spaces like the picture I showed you earlier, where it's kind of in a very short little or compact little growing area. And if we don't get it out of that root limitation space or increase that space, it's going to be the same. We could incorporate something like a systemic plant growth regulator. That's a product that we have that I think is phenomenal for urban settings. We could utilize that and try to get out of the spiral. And if we don't, it's just going to continue to decline. Just skipping ahead here, if we don't do anything and it gets to the gloomy scale phase, we could see intensive plant healthcare program, and that's where Rainbow Ecoscience, that's where everyone that's in the field of actual PHC comes in. It's really important that we see ourselves as kind of this piece of the puzzle to get us out of this spiral of decline. First off, I want to go over drought stress here, guys. Drought stress is going to have so many lookalikes. It's very hard to determine drought stress. With drought stress, some common changes in appearance are, lighter green to yellow foliage or leaf scorch around the margins, wilting leaves and dropping them prematurely. Oftentimes you can see symptoms of stunted shoots, and in some cases more seed production than typically seen in normal years. There are many biotic similarities occurring. A few examples of this could be borer damage. You may see bacterial leaf scorch and oak wilt, bur oak blight, and maybe even anthracnose that may have some similarities between abiotic and biotic. A really good sign of an abiotic condition here is just knowing our weather patterns. If we can understand how much average rainfall we should receive in a single growing season or year, that's usually a good metric to indicate what trees are dealing with and if we need to water them. Widespread tree mortality, I will say, following drought has emerged is environmentally and economically devastating. Some say it's an ecological surprise. I don't think it's a surprise if we're really paying attention to what's going on to the environment. But it is well established that tree physiology is important to understand drought-driven mortality. However, it's very hard to predictions are to base. You can't really base when a tree is all of a sudden going to say, "Oh, I've had enough. Time to decline." So I think that's really important to note as well. We can see that the tree there on the right definitely has some dieback. And another really important note that I want to make here, guys, since we're on this topic, is abiotic and biotic diseases, they are certainly not mutually exclusive. I mean, you could have both abiotic and biotic diseases occurring simultaneously on the same tree at once. And that's what makes our jobs as professionals really hard to kind of identify what is occurring on each host at any given site. I think a lot of times folks, and I have a lot of clients here in Chicago who would ask me, it's got to, like, hey, we know what's happening to our tree, but we would like you to come take a look at it. And I said, okay, well, what do you think it is? Oh, it's bacterial leaf scorch. And so you kind of go into this discovery phase and you say, well, when do you water it? And what you'll sometimes find is those two things are happening at the same time. And so keep that in mind too when you're looking at abiotic versus biotic, because it's not mutually exclusive, and you could see these occurring together at any given moment. Another one here that I always love in urban settings are overwatering of plants. This is oftentimes a really bad, here's a really bad or good example of a tree that's been overwatering. I think it's clear here where you can understand it's overwatered because there's a setting pole just above the root of that tree. That tree in itself probably doesn't like wet feet. And so what we're doing in a setting like that is we're depriving that tree of oxygen, and we're creating an anaerobic condition to where it can't actually, the microbials can't break down nutrients. And so you're really just oversaturating that soil and that environment so that the roots are not able to do the jobs at which they're able to do, and that's to extract nutrients from the ground. It's really important here to see that with overwatering, there's general telltale signs like necrotic symptoms, general needle drop. This could look like a broad variety of different things. Biotically speaking, it could be a borer issue. It could be a frost damage issue. It may even be just seasonal needle drop. It's dependent on the host species. Talking in specifically to this picture here, it's also important to kind of understand that young trees on average will require anywhere from what I've read and I've heard 1 to 2 gallons per inch diameter, depending on the soil condition at any given time. Young trees being anywhere from 10 to 15 years of age. Older trees being over that 15-year mark may require up to 10 gallons per inch diameter, depending on the soil conditions. I say depending on the soil conditions because soils are so subjective depending where you're at in the country or the world. In the Midwest United States, Kansas, where I was from, we had really great fertile soils that weren't really clay heavy. We'll get into soils later, don't worry guys, I won't go down this path, but it's important to note that overwatering is an issue. If you have a client or someone concerned with overwatering, a quick test that I often recommend folks to do is just take a small soil sample at around 6 to 8 inches close to the root, or I'm sorry, the trunk. Make a ball out of it in your hand and then try to squeeze it. And if water comes out of it, we know that's what they call at field capacity. And so that may be too much water. So adding, maybe the best approach there would to not add more water to that tree system. If we have a soil and it's maybe not too sandy and we put it in a ball and it crunches and it looks chalky or something, that's a really good time to indicate that we may want to start our water regime, especially also understanding that if we're in a drought is another good telltale sign that we should probably water a little bit more. Another favorite one of mine, because I live up north in Chicago, is frost and freeze damage. Frost crack is a really cool phenomenon. I think it's probably not, of course, it's not good for our trees, especially in urban settings. We often see this in trees in poor decline. Just there on the left, we can see those big fissures going up just vertically on the tree. This is usually caused because water expands in the tree faster than the tree can adjust to that change. And usually that's with very dynamic changing systems from day to night. It's important to know that generally 50% of the weight of fresh wood is water, and water, when it freezes, expands about 10%. So if we think of that, and we see these trees where there's large fluctuations of temperatures between daytime and nighttime, you often find bark cracking, and usually you'll find it in most settings on the south or the west side of the tree, just because that's the tree that's getting hit with the most sunlight just before it goes to night. And so frost damage is a thing in urban settings. I will say though, maybe those cardinal directions that I just given you are not always accurate, south and west, knowing that we have a lot of buildings in the city that could fluctuate and change that. But generally you see it, and it's certainly sometimes host specific. See it a lot up north on sycamores and maples. Frost damage on new growth there on the right, could be freshly new leaves there on the ginkgo. It can tolerate temperatures. Most trees will tolerate temperatures in the low, and I say most, right? I'm speaking up north to the species that I know. If you're somewhere else around the world, you may have certain hosts that can tolerate way more, but most of them can tolerate temperatures in the low 30s and upper 20s. Freeze damage is likely when temperatures drop into the mid 20s or below, and symptoms will usually include shriveling, browning, blackening, and damaged tissues. Sometimes this can be misdiagnosed, especially if we're talking into herbicide damage as another abiotic. It could look like, maybe anti-desiccation where the water is actually being evaporated. It could be a drought thing. So, and maybe even overwatering, but it's really clear here that this is an abiotic issue. And we'll definitely tell no signs. You won't see any fungal pathogens or mites or any type of disease that are associated with that, depending on the season. Generally, this is early spring, just when you have one of those freakish drops in temperature. Most of the time, trees will recover. However, if it's kind of in that spiral of doom, right, this could be another factor where it may not be able to recover and go into that decline phase if humans or practitioners don't intervene at a certain point. Herbicide damage is a big one, and chemical injury here. There are a lot of categories of herbicides, including growth regulator herbicide like 2,4-D that are causing symptoms of plant and stem curl, twist, and droop. While others, you know, while it can also cause the leaves to crinkle, maybe have these chlorotic kind of splotchy symptoms. We can definitely see that the symptoms are going to be uniform overall. If you do have trees that are affected, it's definitely going to be on multiple hosts, and it's not going to be host specific for sure. 2,4-D being the big one there. It's a growth regulator herbicide. There are other categories of herbicides such as photosynthesis inhibitors, pigment inhibitors, cell membrane disruptor, lipid synthesis inhibitors. And so with all that being said, it's really hard to nail down what herbicide actually caused the damage. But for herbicide damage, I would highly recommend taking samples if you have to and sending it off to lab for further analysis. It's just another important note to keep in mind that this is an abiotic issue, and it's something that we see. Herbicides are always usually applied either pre-emergence or post-emergence. Just knowing when and where that's being done is important. If it's near golf courses or fields, that's another piece of that discovery puzzle that we need to keep in the back of our mind to make sure that we're appropriate on identifying these pressures in our settings. I really like this slide, and if you're, let's say, really good at identifying nutrient deficiencies based on leaf color, this is for you. For me, however, I am not the best at doing this. Specifically, when I look at zinc, sulfur, ferrous iron, and nitrogen, you know, it's hard. It's really rough, guys. If you're in the urban setting and you think you know what that may be, it's always good to kind of take a guess based on the host, if it's a manganese or iron deficiency. But generally speaking, if you're dealing with nutrient deficiencies, I would probably recommend sending this into the lab. I would also recommend taking soil samples. That's going to give you the best telltale sign of what it is you're fighting. I really like this illustration, though. I wish that I could maybe master this in the field of arboriculture, but just another thing to point out that nutrient deficiencies often look like maybe other deficiencies that we see in the industry. Soil conditions here on the right of this illustration is going to showcase unhealthy compacted soils. There on the left, we see a nice healthy soil environment. The big difference is here is when you have a compacted unhealthy soil, you really crunch down on that pore space, and so you don't allow those roots to kind of grow and to uptake nutrients what they need. And so you're basically reducing the way that that tree can obtain its nutrients by reducing the amount of root growth it can get. There's a lot of other factors that goes into compaction that are very bad for trees. In urban settings, we often see this being the case. I will say engineers love compacted soils. Our structures demand that we have sound, safe environments. And so engineers love them, trees do not. In cities such as Chicago, I often see a lot of compaction being done. Tires are great compactors, especially if that soil environment is at field capacity and you roll over it and it's slightly wet, you're definitely going to add more compaction. If you have a soil that's really high in clay or silt, you're even going to be doing more damage. When you compact the soil, you really don't allow that water to kind of percolate as well through. Nutrients then become harder to uptake, and sometimes you can see environments where we have that standing water like we did see in that tree earlier where it had that sitting water on top. Healthy soils, you're going to have no compaction, it's going to be moist, and lots of nutrients are going to be made available. So it needs to have, there's a certain rule of thumb that we'll go over here in the soils category that dictate how a healthy soil profile should look. Improper planting is a big one I see in the city. I think those are oftentimes easy to identify, at least for me. You can see this photo here's got a lot of things going on with it. We've got a root ball that's coming up. There's a sort of structure. I don't know if it's a plastic. It looks like there's maybe string there on the trunk, and so probably haven't removed that. It looks like they removed some portion of the cage, which is good. But another important thing to note here is that is a common abiotic issue that we sometimes see in the environment. Finally, and you guys didn't think I would leave this one out, would you? The infamous volcano mulch. Actually, funny story with this photo. I took this morning across my house in the city. It doesn't look like much here. but that volcano mulch is basically the reason, and in my opinion, this tree, I've watched it decline over the past 5 years. This is a very interesting topic for me because I often see it done at every convention where I'm giving a tree talk or talking about an abiotic issue. Why is this not being mitigated, right? I'm thinking about this, and I'm trying to think above first level. For these trees in particular, I believe that folks saw these roots that were raised above the grass line, and they said, well, let's add some mulch around it so we don't cause mowing damage. Well, maybe that was a great thing to maybe initiate, but over time, you can see that if you're adding too much mulch and you're creating kind of that telephone pole effect, basically what you're doing is you're creating an anaerobic condition now where fungal pathogens and moisture are going to be held proximal to that tree trunk where it shouldn't be. And you're going to create an anaerobic condition where roots are going to look for oxygen, and then you may get strangulation of root systems around that tree. With that being said, this was just this morning right across my house. It was a simple walk, and I said, you know what, it's not going to take me much time at all to find this picture. And so that's a fun little photo I took for you guys. We can obviously see there is a lot of things going on biotic. I did see a sign of mushrooms, and maybe not a new conch, obviously not in the season, but I did see signs of old conchs from mushrooms there and a bit of rhizomorphs. So what is the proper method of mulching? I would say install the mulch around the tree at a depth of no more 2 to 4 inches. Extend the mulch to the outer edge of the tree's canopy if possible. We call that, and some folks call that the drip line. I say if possible. In some of our urban settings, that's just not the case. That could be more than some people's whole backyard. Just get as much of that as canopy as you can. You want it to resemble the bottom of a forest floor so that those microbes and fungi are able to decompose those nice cellulose and all that woody material down at the bottom to recycle the nutrients. It also allows water to be contained. There's a ton of great benefits to mulch. It also keeps boring insects from getting down and overwintering, and so they're not able to parasitize that tree. Make sure there's no more mulch within 4 or 6 inches of the base of the tree. It's a little hard to see in this photo, but keep in mind this was done of spring of last year. It's gone through a whole winter. And I actually took some of that mulch for myself, and they said, what are you doing to the mulch? You're stealing. I said, no, I'm helping you out. I said, you got too much. I'm actually saving your tree, and I'm helping my tree out too. And I kind of walked them through, and we came to a compromise. All of this applies for shrubs as well. It's not exclusive just to trees. All woody vegetation can benefit from this. Another photo, this is just in front of my house here. This is my beloved peach tree. Another abiotic issue here, some structural injury. I live in Chicago. Yes, that tree does produce peaches, about 3, maybe like 2 bushels a year. But the biggest problem is humans come and want to rip the branches. So another abiotic stress there, right? I will say that I've vouched to move this fence, but we can see as that cambium, that tree trunk grows in diameter, the fence is not going to move. The tree is definitely going to move. When you start to dig into that living layer, you're going to start to cause fissures and cracks. Those cracks now open up the tree to a whole host of different diseases and pests and pathogens that attack it. Lesser peach borer. I do treat this tree for peach leaf curl. And actually this year, because I'm seeing a lot of decline, I introduced Cambistat to it. Not going to eat within 1 year if I'm using Cambistat, but I did try Cambistat treatment. So very excited to see what that's going to look like coming this spring. That's fast approaching. I'm often walking out of that door down at the bottom there, and so I'm continuously checking this. Another abiotic issue we often see in city environments is structural damage. Engineers, I think, as we progress in the future, hopefully are kind of figuring this out, like, right tree in right place. Where should we put our structures that make the most sense? Finally, I want to look at one of the most common causes of tree decline in urban environments, and that's going to be this root damage. Don't quote me on this, but I believe I read it somewhere that most urban trees death and decline are caused or initiated by tree root pruning or damage. I think 80%, which is really high margin to think about. So anytime a client asks me, hey, can I remove these roots? I would say no. And I would give them that stat and I say, take that for what it's worth. But there are other things you could probably do. If you do have to do some root pruning, there's some things we can do to help mitigate that. I won't go over this too much, guys. Chlorosis is, we'll go through this really quickly. I only have like 5 minutes and I want to get through some other things here. Chlorophyll is the green pigment found in leaves. When you're lacking that green pigment, chlorosis occurs. It's easily to diagnose in the field by looking at the leaf color. I would say easy. Yeah, generally would be easy if you're, know the host and species. Mild chlorosis will indicate pale green leaves, severe chlorosis, yellow and white leaves. Go through this quickly. There's a chlorotic versus a healthy tree there on the right. We see a nice insufficient root system there on the left, and then a nice healthy root system there on the right. What is it? Chlorophyll is a molecule that a tree uses to make energy for itself. Less chlorophyll means less energy. Less energy means a weaker tree. And we could start to kind of go down that spiral of decline a lot more easy unless we as practitioners come in and try to help that tree out. What causes chlorosis are mineral deficiencies such as manganese and iron. Iron or manganese are absent from the soil, or high soil pH that locks up those cations so they're not easily exchanged with the root system of the tree that's making the hydrogen to make that trade-off. Root system health, if roots are damaged or unhealthy, the tree will not have the capacity to absorb nutrients. Going back to that slide we looked at earlier, the abiotic disease of root pruning or damage is another reason why these trees can kind of start to go in that spiral of decline. Finally, reasons trees can be chlorotic are severe soil compaction, over-irrigation, lawn herbicides, root severing, de-icing salts, root rot diseases, and repeat drought. Another big one, guys, root rot diseases are very hard to identify between abiotic and biotic. Keep that in mind. It's one that I often struggle with myself, including Phytophthora root rot that we're seeing on a vast amount of oaks up here in the state of Illinois. All shade trees are susceptible to chlorosis, but some species are more commonly affected than others. Just want to highlight here the top species in my territory up in the area that I know that are most susceptible. Keep in mind that for common iron deficiencies, you see pin oak, river birch, maple, catalpa, sweet gum, aspen, white pine, and magnolia. Those are going to be common host trees with iron deficiencies. And then manganese deficiencies are going to be a bit different, where you see that on silver, maple, other maples, dogwoods, flowering cherry, and sergeant crabapple. You'll see yellowing in between the veins or newer foliage, necrotic areas developing on chlorotic leaves, tip dieback, and decline on severely affected trees. Again, this is an abiotic issue that could look similar to many other issues. And so it's really important that we're looking at soil samples or analyzing these leaf tissue as we're trying to identify what it is that we're dealing with. Diagnosis could look chlorosis easy to identify by looking at the leaf color. I say easy, I would say in quotations. Sometimes it can be a little bit more difficult, especially when we think back into that illustration of those leaves that show all the different mineral deficiencies. Differentiate between manganese and iron, often difficult to distinguish from each other. I have some companies and practitioners call in and say, hey, can I do a manganese and an iron treatment at the same time? The short answer is if you don't know and you don't have time to send a lab sample, yes, you can do 2 in 1. Just make sure that you're doing it appropriately, doing the appropriate rates depending on the time of the season, so you're not causing phototoxic effects of that tree that you're treating. Most manganese and iron deficiency are diagnosed by common affected species. Again, maples more frequent to manganese, birch and oak are more frequent to iron deficiencies. So if you can keep that as a general rule of thumb as you're working in the industry, just keep that in the back of your mind if you wanted a quick answer and you needed a quick solution to help that client out. Chlorotic trees do not produce as much energy to develop a healthy root system. Trees with an unhealthy root system do not extract the water and nutrients and soils they need for a healthy canopy. Without one of the others, without one, the other suffers. Intervention is needed by us, right, practitioners, and both iron and manganese deficiency often develop a newer growth first. Trees that are severely affected may exhibit tip dieback and become more susceptible to other insect and fungal and abiotic stress. Real quick, because we don't have a whole lot of time, guys, we're going to talk really quick about soils, and I'm so sorry I could do a whole presentation on soils. I love soil. I think it's the future of arboriculture. There's a lot of research that we're looking at and folks are looking at in the industry, indicating that soil is going to be that next pioneer. Matt, my co-host here today, and I were just talking about soils earlier. There's so much going on. Probably there's more interactions that we know that are happening in space than we do in some of our ecological soil environments. So Cool research being done there. Soil trees provide structural support, nutrients, water, and oxygen. Usually the top 6 to 9 inches of soil are going to have 90% of the roots in that first 3. It's important to note that the roots are really looking for oxygen. A lot of times here in the city, when I was a consulting arborist up north, folks would say, hey, I want to remove that tree because it's affecting my sewage line. I would say, actually, your sewage line may be outdated and compromised. That tree probably wouldn't be tapping into that sewage line if it wasn't compromised, because it's looking for oxygen. It just so happens to have water and a nice nutrient environment for those trees to thrive off of too. But you generally don't see roots growing towards water lines because there is no oxygen available. So I always keep that in the back of my mind as well. Roots do stop growing when the soil temps are in the 40s, so they kind of go into that diapause, or that slowdown phase, and it can take 6 months to a year before transplanted trees roots begin to grow. Real quick, our standard NPK, we need these in large amounts: nitrogen, phosphorus, potassium, usually applied as supplemental fertilizers in urban settings. Secondary nutrients such as calcium, manganese, and sulfur, a little bit of amounts, but commonly available. And then finally, and only in small amounts, but get really easily locked up in soil, are the 2 there, iron and manganese. There's a whole chemistry behind the cations there, those positively charged particles, and how they interact with soil that's generally negatively charged. Again, this is dependent on where you're at in the world. Tropical soils will sometimes be positively charged, and so there'll be a kind of a shift there. Real life scenario, this is a soil, this is a plant displaying symptoms of manganese. So if you see something like that, where you got that necrotic, nice haloing ring around the tip end, you may be dealing with something like a manganese issue. Take a soil sample, get it checked out. Quick example of a soil analysis, just showcasing potassium, manganese, magnesium. We see it's very high at 302. However, the pH is around 5.6. This may mean that we're not going to be able to uptake the manganese necessary for that tree to get out of that kind of spiral of doom, that chlorotic symptom. This is something where we may need to mitigate by introducing a soil amendment, or perhaps doing a macro infusion of our product verdure, iron or manganese. We'll go ahead and jump through this, guys. It's important to note that 50% of soils are 25% air and pore space and water. This is an ideal soil there on the right. We also know that soils are made of structures of sand, silt, and clay. There's a nice little soils triangle there. If you have more questions about this kind of stuff, please don't hesitate to ask. We just don't have enough time to go over it today. There's a cation exchange capacity that occurs in our root systems and environment, given a certain pH. And so we know, this is what I was talking about a bit earlier, that clay particle is negatively charged. Tree roots give off hydrogen to make an exchange. So they'll give a hydrogen and in turn take maybe an iron or potassium out of that soil. Tree nutrient, this is really cool. Is it a root development issue or a soil issue? Most rhizophyres, the tree's roots will generate they'll create a more acidic environment by giving off hydrogen amounts. We know that pH is dissolved hydrogen in anything. And so we oftentimes, if we're dealing with an issue of a tree, we should ask ourselves, is the roots compromised or the soil bad? So soil samples, another good reason to take them. Real quick, what are some cultural strategies we could do to mitigate this? We could do proper watering, proper pruning and mulching, reduce compaction and girdling roots. Like we saw earlier in that photo of those that tree volcano, that mulch volcano out front. I'm sorry, tree volcano, mulch volcano out front. We could use this with an air spade, and we could also do prescription fertilization, maybe incorporating plant growth regulators like our product Cambistat. Proper watering is important. We can see here that they're there on the left, they're doing a overcast watering, maybe at a certain time of the day that's not good for those trees. Could initiate fungal pathogens to start growing, such as Rhizosphaera, and needle cast to start initiating that spiral of death. So just understanding down the right may not be the best way to water trees. We may want to do a nice slow trickle. Here in Chicago, I've had clients that have done 5-gallon buckets with a few holes drilled in the bottom, and they'll leave it setting over a 5-hour period of time. Cool things like that are out there that folks have gotten creative with. I think it's really phenomenal. And so just keeping that in the back of your mind as you're going throughout your day. Proper mulching, again, if you can mulch as much as that underneath that canopy. That drip line as you can is great. Grass, we know, competes with nutrient uptake with trees, and so it's not always often good to have grass growing up to the trunk of the tree. Dr. Gary Watson at the Morton Arboretum did this really cool study here showcasing grass and mulch. And we can see with the mulch layer, there's definitely a lot more microfibrous root growth, which is phenomenal. A nice study that was also relative to this is we can see with no mulch there in the solid kind of lines, we get relative growth rates that's much less than when we incorporate mulch. We'll just kind of run through this, guys. Soil enhancement's important. If you're going to do a soil enhancement, if you have questions about it, I'd be more than happy to help you out with that. Just making that environment better for the trees if you're dealing with compacted soils are important. Introducing more organic materials and airspace and pore space for those tree roots to grow. And then applying paclobutrazol on some of those more compacted environments are always great. Paclobutrazol being our growth regulator cambistat. You can do soil fertilization plans, which are really important in urban environments. And this could include pH conditioners. Kind of run through this really quickly. There's other treatments out there. If you're doing a injection for iron or manganese, we would here at Rainbow Ecoscience say use verdure, utilizing a macro infusion injection. I say macro because you're going to need a certain amount of water to get up into that tree canopy so that you get equal distribution throughout the whole canopy. If you're using lower amounts of iron and you're expecting green up, you may be getting green up for 1 year and you may not get equal distribution. So make sure if you're doing injections for chlorotic issues with iron or manganese, just make sure you're doing it the most appropriate way. I would say the industry standard being macro infusion. And use that to stimulate chlorophyll production. Here's a cool photo between 2004 2011 of after a treatment utilizing verdure. We see a significant change there. You also get some of those treatments with cambistat. Quick illustration, micro versus macro. Micro there on the left showcasing how it doesn't really get up in the canopy, and sometimes you need to do macro injections, just adding more water so that those molecules are able to get up into the tree. If you don't have enough water, guys, and they're just not going to make it. It's not practical, especially when you think of a tree as being 50% water. We'll go over humectants. This is cambistat. I can do a whole webinar about cambistat in itself. If you have more questions about cambistat or plant growth regulators, I'd be more than happy to help you out. Phenomenal product, and I think it's going to be used heavily in the industry as we progress throughout urban environments. A little bit of studies there between treated and untreated, utilizing cambistat. And then finally, we see some more results here with Dr. Gary Watson at the Morton Arboretum. With that, guys, I am coming to time, and so I'm going to cut it a little bit short. I do apologize. I got really hyped up on pretty early on, and so let's go ahead and do a Q&A. Matt, I don't know if you want to just narrate this, and we'll try to solve as many of these questions as we can.
Yeah, no problem. Thanks, Cory. Thank you all for joining us. I do understand we are probably about to go over about 1 minute to noon. If you do have to jump off, that's totally fine. You still will get the CEUs, but we will start running through the questions here now. All right, so let's see. First one, how do you use plant growth regulators to help urban trees?
That is a great question, Matt, and I would say it's very dependent on the scenario that those trees are put under. In many cases, we can help urban trees fight drought or stress because the way that the paclobutrazol, that active ingredient, kind of shuts off the stomatas of the leaves. We can also inhibit growth of maybe the larger buttress roots, while also inhibiting more growth of the finer root structures that are needed to take in nutrients and exchange for that tree. We also know that plant growth regulators do create more chlorophyll pigmentation due to the trade-off of not having that lateral growth, so that energy is redistributed elsewhere. Because you get more chlorophyll production, you generally get more energy production, which that energy is then put in cells for growth or storage or energy. And so it's very dependent on the scenario. I used it a lot after construction, or I used it a lot in association with chlorotic symptoms and diseases.
All right. Next question. Are you experiencing any experience or information about mature tree failure of graft at base? And then it has Tilia cultivars in parentheses.
You know what, Matt, could you go ahead and read that again for me, please?
Yeah, absolutely. So do you have any experience or information about mature tree failure at graft at the base? And then I think they mean in specific Tilia cultivars.
That is a great question. I don't have a lot of practical research or evidence that I know of that happening. So I don't really know the answer to that one. Not for Tilia specific, no.
All right. And then the next one, in your recommendation for how much water per dBH you emitted the frequency, can you please indicate the frequency per gallon?
Yes, I can. Thanks for asking that question, Naomi. I think it's important to know the frequency of dBH per gallon, but really I would say just stick to that general gallon per inch diameter and base that off of your soil conditions, right? Soils are going to be dependent, and some soils are going to hold moisture more than others depending on the weather. And so really I would say base it on what the soil conditions look like. And that's how I would address it. Make sure that the folks are out there knowing what field capacity are, and if those soils are very saturated or very dry, understanding if it's clay or heavy silt, it may be able to hold more moisture or not allow it to percolate through.
Right. Next one is magnesium, not manganese, right? I think they
Yes.
were talking to the soil test that you had.
Yes, probably so. If that's a soil test, yeah, my apologies.
All right, next one. How well does Camostat work for drought stress mitigation in arid climates?
It depends how arid it is. I will say it works exceptionally well if you're not dealing with high rates of drought. Arid climates, you have to keep in mind, anytime you're doing a chemical application, this is really a kind of approach to help mitigate those underlying issues. Those trees still need to be watered, and if they're the wrong tree planted in the wrong spot, perhaps, Campostat's only going to stave off those conditions. But other than that, I say it works really well. You start to see, again, I wish I could have gone more into depth over Campostat, but what it does is you create a scenario where the stomatas are not opening due to those guard cells being closed more proximal, and so you don't have much transpiration in times of drought. You also get more chlorophyll production, so it does create this reserve that helps that tree just overcome stressors. It's not a clear percentage I could put on it, but I know it does help significantly. There's a lot of research out there that would indicate that.
All right, next question. Can you talk more about paclobutrazol? It's saying that it helps with compaction, if they heard that right, and can you explain more?
Yeah, sure, certainly, Jeff. Talking into that, does it help with compaction? I would say not initially, no. You have to do maybe initial procedures like air spading, ameliorate that soil, kind of create an environment to where that tree is going to thrive under, adding in biochar and maybe other amendments to help it, but also including Campostat in there as well. Again, I would say it helps because you see a lot of secondary benefits. I wouldn't just apply Campostat without decompacting a little bit of that soil. You could if you wanted to, but you may not see the full effects of what that product could do.
All right. Next one, are we doing any research on biochar applications?
Jennifer, that is a great question. At this time, I do not believe so, but send me an email and I'll follow up with our R&D team to see what we have going on there.
Next one, are all paclobutrazol formulations at 22.3% active ingredient the same?
Active ingredient, 22.3%, I would align upon. It's the inert ingredients that I would say maybe have some subjectivity. Understanding that paclobutrazol, 22.8% is a molecule itself. Unless you're changing that molecule, that is the formula for that ingredient.
All right, and it looks like the last question we have is, can you describe what Campostat actually does?
Hey, Jeff. Yeah, I would love to answer that question. Keeping in mind, Cambistat is probably about an hour presentation. So the quick and the dirty thing is um, it suppresses a hormone called gibberellic acid that's secreted in the apical meristem, so the tip ends, kind of the dominant bud. When you suppress that hormone gibberellic acid, you initiate a secondary response, kind of the plant defense hormone abscisic acid. And when you do that, you create an environment to where that energy is now being distributed differently in the tree itself. That energy distribution, now that you're not putting in lateral growth, goes into root development. It goes into more chlorophyll pigmentation creation, so you get more sugar creation for the tree. You get more finer root development. There's about 14 or 15 reasons that I could think of to list off why Cambistat could be used in environment. That's the quick science. We could get more deep into the isoprenoid pathway. But if you have more questions for me, I would love to give you more information via email. Please don't hesitate to reach out to us. We could definitely backfill you in on what Cambistat truly is and how it works at any time in your career or life.